In this lesson, we're going to be looking at two new parent functions, y equals secant x and y equals cosecant x. Let's start with y equals secant x. Let's go ahead and look at it from a graph. Make sure you're in radian mode. To graph secant x, remember we don't have a secant key, so we can think of y equals secant x as 1 over cosine x. Okay, we're going to do our zoom 7 window. Okay, so as we kind of observe the graph here, it appears that we have these parabolic shaped pieces of this secant graph that are alternating, opening up and opening down. So when we talk about the period, okay, it's not going to be that we just have one upward or one downward opening parabolic shaped graph. To complete one period, we're going to need both an up and a downward appearing parabolic graph. All right, so remembering our window, remember that these scales are pi over 2, so pi over 2 pi. So it looks like at pi, I'm down here, it looks like y equals -1. But if I move over here to 2 pi, it appears that my y value is 1. So when we graph this by hand, we'll be able to see all the little details of why this graph looks the way it does. And before we do that, I want to go back to y equals and show you something. Remember that secant is the reciprocal of cosine. So on y2, I'm going to graph cosine. It's kind of a neat thing. I'm going to actually left arrow back over here, and I'm going to change up the type of graph. So I'm going to press enter. So when the calculator goes to graph cosine x, it's going to graph it in a more heavily darkened graph. It's kind of interesting because when you think about the cosine graph, at the peaks and the valleys, at the highs and the lows, at the maxes and the mins, those are the places where we're going to have the upward or downward opening parabolic shaped graphs. All right, so let's go ahead and fill out our t-chart and then plot by hand. So we're going to need the unit circle again. All right, so if x, the angle, is -pi, we're over here. Secant's the reciprocal of cosine, so the reciprocal of -1 is -1. All right, let's go to -3 pi over 4 on the unit circle, which is right here. Secant's the reciprocal of cosine, so let's reciprocate, flip, -square root of 2 over 2. So I am going to find the value of -2 over square root of 2. So I just reciprocated it to get secant. Press enter. I'm going to get -1.4 is what we'll record since we're graphing. -1.4. All right, what happens at -pi over 2? Well, -pi over 2 is down here. The reciprocal here would be undefined. So it looks like we're going to have a vertical asymptote, which that graph did suggest there were many. All right, so -pi over 4 is the reciprocal of this x coordinate, so that would be +1.4. So if you're comfortable generating this column of values, secant values, then just pause the video and fill it in and then just rejoin. Where are we at? 0, that's 1. Pi over 4 is a positive. And at pi over 2, if I reciprocate 0, I get undefined. So it looks like the vertical asymptotes are happening at like the half pi's, not the whole pi's. 3 pi over 4. 5 pi over 4. 3 pi over 2 is coterminal with -pi over 2, so it looks like that's undefined. And this would be 1.4 and then 1. All right, I didn't leave myself enough room here, so we'll put the graph down here. Actually, I am going to move this y-axis over just a tad. All right, so -pi maybe is right here. positive pi, and 2 pi. And then for the fourths, we'll just fill in these tick marks. All right, as I observe the values down this column, it appears, in thinking about the graph that we looked at, it appears that my parabolic shaped graphs continue up to infinity and down to negative infinity. So I think I'll just put a 1 right here, maybe a 2 right here. Okay, and then let's plot some points. Negative pi, negative 1. So negative 3 pi over 4, but I got to go down to about right here. At negative pi over 2, I have a vertical asymptote. And I might just fill all those in. At pi over 2 and 3 pi over 2, I also have vertical asymptotes. All right, thinking about the graph that we looked at on the calculator, I think that this is going to be the maximum on that downward opening part of the graph. And the graph is probably going to continue down like this. Had I had more values under the x column that are smaller, then the graph would have gone something like this over here, with a vertical asymptote likely at negative 3 pi over 2. All right, back to graphing. I'm at negative pi over 2, so now I'm at negative pi over 4, which is here at 1.4. 0 is at 1, and pi over 4 is at 1.4. So this is going to take on the shape of that upward opening parabola that has this little minimum here. We're at pi over 2, 3 pi over 4, so 3 pi over 4 is here. Back down to about here. At pi, I'm at negative 1. 5 pi over 4, I'm down here. So based on what I saw, I know the graph to do something like this. We're at the vertical asymptote. 7 pi over 4 is up here at 1.4. And at 2 pi, I'm over here at 1. So according to my t-chart, I've just kind of cut off some parts of the parabolic shaped graph. But if I wanted to complete this graph, I know that I would just turn it back upward and have another vertical asymptote probably over here at 5 pi over 2. All right, just some observations. If we talk about the range is going to be coming up from negative infinity, but we'll stop at negative 1, and then there's this gap until the graph starts again at 1. So for the range, we're going to have two pieces, negative infinity up to negative 1, put a bracket. You can either do union or a comma. Okay, that graph doesn't start again until 1. It goes up to infinity. And remember the cosine graph that slipped in here? Well, if you remember, the cosine's range goes from negative 1 to 1. So it's cosine's range is everything that secant's range is not. All right, let's talk about the domain. Or I'm sorry, let's talk about the period. All right, well, I can't say that the period is pi, because if I did, I would only have either one upward or downward opening part of the graph. So it's going to take one up and one down to complete an entire cycle before it starts to repeat again. So notice that the period will have a length of 2 pi, but in between, halfway in that period, you're going to have another asymptote to separate the up and downward parts of the graph. So the period is actually the distance between negative pi over 2 and 3 pi over 2. It's this distance right here, horizontally, so that period is 2 pi. This period's the same as cosine. And that makes sense, because cosine is the reciprocal of secant. All right, let's look at the equation that represents the vertical asymptotes. Vertical asymptotes occur at x equals, the first positive one is pi over 2, plus n times, you might be used to multiplying n times the period, but remember, halfway in between this period is another vertical asymptote. So we're going to multiply n times not the period, but half the period. So n times half this period would be pi. So these are the same as tangents, vertical asymptotes. So if that's something that might help you memorize some of this information about secant, well, then that's great. And the domain would just be all reals except where the vertical asymptotes occur. All right, let's go ahead and complete the cosecant parent function as well. So we'll start by graphing that on the calculator. I'm gonna come over here. Cosecant's reciprocal is sine, so I'll just change that function. And then here I'm gonna turn this off for the time being by unhighlighting the equal sign. So I'll graph. So cosecant looks almost identical to secant. It just looks like it's been shifted to the right some amount. And that right to the amount is going to be pi over 2. Looks like it has the same range. Of course, the vertical asymptotes will be different. It looks like it has the same period of 2 pi. Let's go ahead and go back to y equals. So sine's reciprocal is, or cosecant's reciprocal is sine, so I'm going to change this function to sine. It's been turned back on because the equal sign's highlighted, and I'm going to graph it. So there's sine. So if you forget what cosecant looks like, maybe if you remember sine's graph, you could draw it, and then at the high and the low, that's where we're going to have upward and downward opening parts of the cosecant graph. All right, so let's generate these values. If you're comfortable, pause the video, do it, and then come back and just check. All right, at negative pi, I want the reciprocal of sine, so let me get the unit circle. At negative pi, here we are. The reciprocal of the y-coordinate is going to be undefined. So vertical asymptote. And then we'll just populate all these. So negative 3 pi over 4 is here. The reciprocal of the y-coordinate is going to be negative 1.4. This will be negative 1, negative 1.4. We're at 0 radians. The reciprocal of the y-coordinate is undefined. Pi over 4, pi over 2. We're back at pi. That's going to be undefined. Vertical asymptote. And 2 pi is another undefined. I'm going to go ahead and fill in the vertical asymptotes. And their pattern would just repeat. So what it takes is one up and one down part of the graph to complete one cycle. So that horizontal distance covered is 2 pi. But again, halfway through that period, we do have that vertical asymptote to separate those two parts of the graph. Okay. So I'll just deal with the range. It's going to be the same thing as secant. We have a gap between y equals -1 and y equals +1. Period is 2 pi. It's going to be the same as sine, since cosecant's reciprocal is sine. And the vertical asymptotes occur at x equals 0 plus n pi. Not n times 2 pi, because on the secant and cosecant, halfway in between that, we do have another vertical asymptote. So think of half of 2 pi, which is just pi, and multiply by n. And I will leave off the 0 and put n pi. Oops. All right, so those are our parent functions, and then we'll just begin graphing some other secant and cosecant functions that have transformations.